Hello friends, all TYBSc Physics Special students appearing for final examination to be conducted by Savitribai Phule Pune University Pune in October 2020. In today's discussion, we will see few important multiple choice questions on the topic nuclear energy and reactors from the syllabus of nuclear physics paper 4. Please note, many questions here which we are discussing are taken from the website www.sanfoundry.com. You can check out this website for few more questions, and answers are again given very nicely. So this session is totally dependent upon the questions which are based upon this nuclear energy and reactors. So let's come to the questions. Question number 1. The nuclear fission is the phenomenon of, four options are given: heavy nucleus splitting, B. heavy nucleus combining, C. light nucleus splitting, and D. light nucleus combining. So as we have already seen, in the fission, heavier nucleus gets broken into two smaller nuclei. So this process is called as fission, or this is also called as splitting. So naturally option A is correct for option 1. Heavy nucleus combining is never possible, as well as light nucleus splitting is also not physically possible, and light nucleus combining, that is nothing but our fusion reaction. So this option 4 gives you fusion, and option 1 is fission, and therefore question number 1, first option or A option is correct. Then Q value of the fission reaction is of the order of, question number 2. Here if we go on calculating the mass before interaction and mass after interaction or after the reaction, you find that mass before the reaction is slightly more than the mass after the interaction, and that is what the amount of mass disappeared gets converted into energy. And if we go on careful calculation for this fission of uranium-235 with this thermal neutron, this number comes to be 200 MeV approximately. So therefore answer of question number 2 is C, 200 MeV, million electron volts. Question number 3. An atom bomb is A. Option A, controlled fission reaction, controlled fusion reaction, C, uncontrolled fission reaction, and D is uncontrolled fusion reaction. So basically there occurs a chain reaction, and this chain reaction is that when first nuclei undergoes reaction, whatever neutrons generated in that case, these neutrons can be used for further fission, and thereby one after another this reaction can be carried out. But here in case of atomic bomb, we do not apply any control mechanism. Therefore this type of chain reaction or chain fission reaction becomes uncontrolled one, and therefore C is the correct option, uncontrolled fission reaction. Whereas controlled fission reaction takes place in the nuclear reactors, then uncontrolled fusion reaction that also can be carried out in the laboratory, as well as uncontrolled fusion reaction that we see, that is the basic source of energy generation in most of the stars that are found in different galaxies. Then question number 4, average energy of neutron produced in fission of uranium-235 isotope is. So again, as I said earlier, in this entire reaction, total amount of energy released is almost 200 MeV, and out of that 6 MeV is the amount of energy taken by 3 neutrons. So on an average, every nuclear reaction or fission reaction gives 3 neutrons as an output particle or outgoing particles, and the total amount of energy undertaken by this type of neutrons is almost 3% or 6 MeV in calculation. Therefore each neutron carries approximately 2 MeV of amount of energy with it from this reaction, and therefore option B is the correct for question number 4. Question 5. The moderator commonly used is amongst this diamond, graphite, lead and copper. You will note that in this case The moderator is basically a component of nuclear reactor which slows down a fast moving neutron, and further these neutrons are made available for causing further fissions, and this slowing down is the process which is carried out with the elements or the materials which are having tendency of not absorbing these neutrons, but they are just reducing their energy, getting energies out of these neutrons, and this responsibility is correctly um, is this responsibility or this type of reaction can be carried out with the graphite. So amongst given four elements, this graphite is the most proper element or commonly used moderator in all nuclear reactors. Then question 6, when multiplication factor is greater than 1, the power increases linearly. If I plot a graph of effective multiplication factor K versus time, for a successful working of this nuclear reactor, we have to maintain this K is equal to 1. If this K goes down, this step is called as the subcritical, or in this case the rate of reaction falls down abruptly and this reaction completely stops. In some other case, if this reaction this multiplication factor goes becoming more than 1, in this case you will find this step is called as supercritical or supercritical state of the nuclear reactor, or that is what a nuclear explosion, and this is the critical state. So nuclear reactor goes critical means we are maintaining its multiplication factor to be equal to 1. So here the power is linearly given out, and therefore it is not possible for a nuclear reactor wherein K is greater than 1 or it is increasing, it is supercritical state. In that case, this type of power increase doesn't linear, but it is going to be exponential, and therefore the given statement is false. So option B is the correct option for question number 6, which tells you that if the effective multiplication factor K is greater than 1, then the power doesn't increase linearly but increases exponentially. Therefore option B is the correct option for this question number 6. Then question 7, another important component, that is called as reflectors, are used in nuclear reactor to control the speed of the neutrons. Earlier we have seen this actual work is done by moderators, and so this slow down this fast moving neutron. Therefore reflectors does something very important, that from the core, if there are some neutron generated and they are giving out, this is called as leakage neutron, and these neutrons are, once they are leakaged out, these neutrons are not available for further fission. So these neutrons can be reflected back into core again by these materials, that is reflectors. Therefore this is the functioning of reflector, to reflect back the neutrons which are leakaging out, and therefore reflectors are used in nuclear reactor to control the speed of the neutrons is a false statement, and therefore option B is the correct for option number question number 7. Question 8, the safety rods present to shut down the reactor are made up of. So again this is another very important component of the nuclear reactor. These safety rods, this is what a core, and these safety rods are inserted from several different sides. These safety rods can be inserted or can be pulled out, thereby these fast moving neutrons are actually absorbed. So absorption process takes place while these control rods are inserted in the core as well as pulled out, and thereby we can control the rate of the reaction, and this is done by very nicely by the elements which is said to be cadmium. So cadmium has a very high reaction cross section with this fast moving neutron, therefore it can easily absorb these fast moving neutrons, and thereby rate of the reaction can be controlled. Or even if we want to stop this reaction, then pull these rods inside, well inside this particular core. So most of the neutrons that are created in the earlier fission reactions, they are to be absorbed, and then this reaction completely stops. So cadmium is the correct option of question number 8. Now number 9, the neutrons slowed down by the moderators are called as. There are 4 options given: slowed neutrons, thermal neutrons, fission neutrons, and moderator neutrons. So in general, in case of nuclear reactors, moderators are basically used to reduce the speed of fast moving neutrons and make them their speed to be equal to the speed given by this equation. that is 1 by 2 times K into T, where this K is Boltzmann constant and T is the absolute temperature or room temperature. Absolute temperature, that is room temperature, and this type of neutrons are called as thermal neutrons, and these neutrons are useful for carrying out further fission reaction, and thereby continuous chain reaction is possible or controlled chain reaction is possible. Therefore correct option, so slowed down neutrons is not correct. So these are the thermal neutrons, and thermal neutrons are the neutrons which are having their energy given by this equation 1/2 times kT. So B is the correct option of question number 9. Then question 10 is related to the prototype, or the different types of components are shown there. So following is the diagram of nuclear reactor. Identify X. So we should identify this Y is a core, then this Z are the control rods, they can be inserted or pulled out, and this X is a reflector, so this can be shown here, and the space ends outside this core and this shield. This is a shield here and this is heat exchange or heat exchanger. So this is the different types of components of this. So this shield is supposed to be have a material outside that. This should reflect all the leakaging out neutrons, and again these neutrons are made available for fission inside this core. So therefore the identify X here. So X is this particular component of the nuclear reactor, which is nothing but the reflector. So core is Y, control rods are shown by letter Z, and coolant here, if it is represented by C, so that can be shown to be a coolant here. So in general, any nuclear reactor has this minimum basic type of components, and each component has its own functioning. This is to be understood while understanding the working of the nuclear reactor. Then question 11, at high temperatures, which material is the best choice to be used as coolant in a nuclear reactor? So water is first option, heavy water is second option, C is molten sodium, and D is the molten carbon. So in nuclear reactors, at very high temperatures, the water boils at only 100 degrees Celsius. Therefore it is not a efficient coolant, or that cannot take entire heat generated inside the core to the surrounding, and therefore in that case molten elements like sodium etc. they can be used. So at very high temperature, this molten sodium etc. these are the best coolant used in the nuclear reactor. So otherwise you have to pressurize this water. So pressurized heavy water is also used sometimes. Pressurized heavy water, because we know that if we give a more and more pressure on this particular water, then its boiling point increases, and thereby it can take sufficient amount of heat from core to the outside of the surrounding of this nuclear reactor, so to the heat exchanger. So therefore either we can use pressurized heavy water, or we can use this molten sodium type of elements for efficient cooling. Then question 12, a nuclear fusion is the phenomenon of, already we have seen, this is what a phenomenon where two lighter nuclei they combine together and they give rise to a heavier nucleus, and this particular process is called as fusion. As we all know, this is the one of the important process wherein this process gives out the maximum energy inside all stars or the extragalactic objects there where this type of nuclear fusion reaction takes place. Therefore light nucleus splitting is not correct, heavy nucleus combining is also not correct. Heavy nucleus splitting is nuclear fission, already we have seen. So light nuclei combining, this is the correct option for question number 12. Question 13, the fusion reaction takes place under. Now for a fusion reaction, to bring two protons very close to each other, there is always an electrostatic repulsion. So we have to overcome this repulsion. That's why these protons are supposed to be needed to give a very high energies. Therefore high temperature is needed. At the same time, if density is very less, then again the occurrence of the reaction will be very small, and therefore we require very high density also, or high pressure. So high pressure and high density are the requirements, initial requirements for any fusion reaction to take place. All these conditions are found there inside the core of the star, and therefore inside and the core of the star such type of fusion reactions takes place, and therefore the option number C is the correct option for this question number 13. That is, high temperature and high pressure is required for fusion reaction to take place in the stars or like that objects. Question number 14. Which process happens inside a star? Just now as we have seen, inside star, this hydrogen atom 1H1 that gets converted into twice He4, and in that process certain amount of mass is lost, and this mass gets converted into energy, and this process is nothing but nuclear fusion. So that is the basic source of in the generation of energy inside stars, that is the nuclear fusion. So lighter nuclei come together, they diffuse or fuse, and they give out a heavier nuclei. In that process certain mass is lost, and this mass gets converted into energy, and this reaction is called as nuclear fusion reaction. Question number 15. The two types of cycles proposed in the star for fusion are, so there are four different options given: PP cycle and PE cycle. There is no such cycle here. Then PP cycle, proton-proton cycle, and carbon-neutron cycle. This is the actual correct answer. But let's see, this is PP cycle and PC cycle. This is also not there. PP cycle and PN cycle, this type of cycles are not there. So here PP cycle and CN cycle, these are the two basic sources of generation of energy. Thereby in both the processes 4 hydrogen atoms, so 4 1H1 that come together, and that gives you twice He4 or helium nuclei. And in that process, as we have said earlier, certain mass is lost, and this mass is converted into energy, and this is the amount of energy generated in this type of nuclear reactions. And therefore PP cycle and CN cycle are the common source of generation of energy inside stars. Then in proton cycle, the hydrogen and deuteron fuse to form. So therefore we can write this very simple reaction. So this is first nucleus is 1H1, and second is 1H2. This is deuteron, this is simple hydrogen or proton, and this gives rise, when I go for this reaction, this proton number will be 2 or atomic number is 2, and here this 1 plus 2, this nuclear number will be 3, and this is the element which is nothing but twice He3. So this is isotope of helium, and therefore in the given options, option C is the correct option, which gives you helium-3 is the element which is generated in this process as shown above. Then next question number 17. In the carbon-nitrogen cycle, nitrogen acts as nuclear catalyst. So we have to identify whether the statement is false or true. So in carbon-nitrogen cycle, I think you might be remembering this. In carbon-nitrogen cycle, initially carbon element is there. Along with that, in this process, again 4 hydrogen atoms are combined together, that gives you twice He4, and carbon atoms remains as it is, and another new element is generated, that is the nitrogen, and therefore this carbon works as a catalyst and not the nitrogen. Therefore the given statement is false, and therefore option B is the correct, that in carbon-nitrogen cycle nitrogen acts as a nuclear catalyst. This is false statement. Carbon works as a acts as a nuclear catalyst. Question number 18. The Q value for both PP cycle and CN cycle is same. So again identify true, false, neither true or false or none of this. So this statement is a true statement, because even though it appears a PP cycle or CN cycle, in both the cases, as I said earlier, 4 hydrogen atoms disappear or fuse together, and that gives me twice He4. So this is the process, same number of atoms are disappear and one number of new nuclei has been generated. So in both the processes, even though this carbon-nitrogen cycle, nitrogen cycle or PP cycle, the amount of energy liberated is just same, and therefore statement true, this given statement is true. Therefore option A is the correct option for question number 18. Then 19. What would be the effect of nuclear holocaust? Now this is the holocaust. It is a concept when not many number of nuclear devices are exploded. In that case, what will happen there? It is an imaginary situation. On the earth, this type of nuclear dust will be generated from all sides, and this dust will not allow to enter the sun rays on the surface of earth. And whenever this type of situation occurs, there will be immense cold situation will be there, because so no sunlight will be allowed to enter on this earth surface, and this particular phenomenon is called as holocaust. And therefore in holocaust there is a great chance of having enough cold or lot of cold and that will be a situation like winter. Therefore, nuclear winter is said to be the outcome of this nuclear holocaust. Of course, this is an imaginary situation, but it can be predicted based upon the picture what we have drawn here. Question number 20. The unit used to measure the dose of radiation. So dose of radiation, so again these options are given. Joule is used for energy or work done. Rontgen is the basic unit that is used for measuring the dose of the radiation. Nuclei, this is not the correct at all. None of the above is not there. So B is the correct option of this question number 20. That is, Rontgen is the unit used to measure the dose of the radiation. And the last question number 21. What should be the product of this fusion reaction? So that shows you deuterium atom is coming here. This is a tritium atom. So we can write this reaction as 1H2. This is deuterium, and tritium is 1H3. So if I write this reaction on the right hand side, there is already one neutron. So this is 0N1. One neutron is there, one proton is there. So total number of protons before reactions are 2, and to balance this, and total number of nucleons are 5. 2 plus 3 is 5. Already 1 is there, so this will be 4. And we know that the element which is having 2 protons and 4 nucleons is nothing but helium. So in this case, this is the element which will be generated in the process, and therefore helium 4. B is the correct option for this question number 21. So thank you for patience listening all our questions. I suppose that with the help of these questions, it will be easier for you all to appear for the coming examination. Thank you once again.